First of all, belated happy Diwali wishes to you all, and I know there are many more to come. So yeah, many more festivals will follow. We have just started the festival season. So Anjika is the new member in this class. So warm welcome to Anjika, and we'll get started. So as you all know, this is for SAT preparation. So all of you are getting ready for SAT exams, and this class is primarily meant for figuring out all possible ways of how I can be of minimal help to you guys in the journey of your preparedness for SAT. So we talk about the concepts, we learn different concepts, we practice some of them, and I don't give assignment to you guys, but my expectation is that whatever we learn in the class, you guys are kind of doing some unit test on Khan Academy for the related topics, so that you are keeping pace with what we are learning, and you're able to apply those concepts in your while practicing or doing the unit test on Khan Academy or anywhere else. So let's start. So we had started with permutation in the previous class. So we talked about what is permutation. Any of you having any doubt about what is permutation, whatever we have learned, anything that you think is not clear before I move on? Yes, Aura. Hello. So, okay. So just a quick recap. When you talk about permutation, in simple terms, Neil, when you talk about permutation, it is nothing but a way to arrange certain things. Let's say if I have 4 people, and they have to sit on 4 chairs, there are different ways we can organize them. Let's say we have 4 chairs, A, B, C, these 4 chairs, and we have to make 4 people sit on these. And we can make them sit like this, we can make them sit like this, we can make them sit like this, and I can literally go on. There are different ways to do that, right? So when you talk about permutation, when you talk about permutation, you are essentially talking about arranging certain things, keeping the order in mind, meaning ABCD and BACD are 2 different permutations, 2 different ways to organize them, and that is why it is called permutation, meaning you are mutating the way things are organized, right? And that is why in the last class we talked about how the mutation of coronavirus was relevant to the people who were trying to find out vaccine for it. So in simple terms, permutation is nothing but a way you can organize certain number of things, and that is when we talked about, let's say, going back to the same example, let's say if I have 4 chairs and 4 people to be organized, seated on those chairs. First chair I can pick in 4 different ways. If I have 4 people, I can pick in 4 different ways. Second chair, I can make people sit in 3 different ways, because one person is already gone here. So we are left with 3 people and 3 chairs. So that when I'm trying to fill the second chair, I have 3 options to pick from. Similarly, the third chair, when I'm trying to fill, I have 2 ways to do it, because one person is occupied here, another person is occupied here, and then I'm left with 2 people and 2 chairs. I can pick a person for the third chair in 2 different ways. And then this converts into the total number of combinations that we can look at. It's 4 times 3 times 2 times 1. And this is what we call as factorial 4. Up to this much, you guys recall what we have discussed? Okay. Ritika is the first one to say, I'm tired of hearing the same thing again and again. Let's move on. Yeah? Alright. Now comes another thing that we tried touching upon, and let's look at this. So far we were talking about 4 chairs, 4 people to be filled up. 4 people to be seated on those 4 chairs. As long as you're not playing the musical chair, where the number of chairs is less than the number of people, you are still fine. So you have, if you have, let's say, 5 places to be filled, let's say you have started a club and you have 5 places to be filled and you have 5 friends, you know that you can arrange them in factorial 5 ways. Yeah, I mean these 5 positions are like, you know, CEO, financial, CFO, your secretary, your, you know, let's say a team member, and some, let's say a treasurer. So you have factorial 5 ways to arrange it. So far this is okay. Now what if you have 5 places to be filled and you have only 3 people? How many ways you can fill them? Or let's do it this way. Yeah, okay, that's fine. So you have 5 positions to be filled and you have only 3 people. Or let's flip this. So let's say you have 5 people and you have to fill 3 positions. First position you can fill in 5 ways. That's okay. Second position you can fill in 4 ways. Third position you can fill in 3 ways, because you are picking one person out of 5. So you have 5 options and you fill the first position. Second position you can fill in 4 ways. One person is gone here, remaining 4 people. You will choose an option. And third position you can fill in 3 ways. Now the total number of options that you have is 5 times 4 times 3. This situation versus 5 positions to be filled by 5 people. Here you have 5 options, 4 options, 3 options, 2 options, 1 option, and total number of permutation that you're talking about is 5 times 4 times 3 times 2 times 1. So these two situations, if you try evaluating them, what is the difference that you are seeing? Here I will say 5 people to fill for 5 positions. So 5 permutation of 5. This situation is 5 permutation of 3.
Hi sir, sorry I lost track of time, so I wasn't able to join.
No worries, beta. But just a quick recap. Whatever we are doing right now, you have not missed anything so far. We are just doing a recap of what we learned with respect to permutation. Okay, so we are just looking at 2 different situations where I have 5 positions to be filled, 5 people. We can do in factorial 5 ways, or we can represent that as 5 permutation of 5. Here I have 5 people, but I have to fill only 3 positions. So the total number of options I have is 5 multiplied by 4 multiplied by 3. Now if you compare these 2 situations, this is 5 permutation of 5 and this is 5 permutation of 3. This equals factorial 5 and this equals something different. It is not factorial 5. If I try making it factorial 5, then that means I'll have to multiply it by 2 and 1 and then divide by 2 and 1, so that I'm not changing the value here. Are you guys able to follow me so far?
Yes sir.
Everybody? Anjika, it's a new class for you. Are you able to keep pace with the teacher? Am I still making sense to you?
Yeah, it makes sense.
Okay. So there are two situations that we're talking about. So what is that you observe here? When I have to fill 5 positions with as many number of people, this is my situation. And this is my situation here in this case. And how I can relate this? 5 permutation 3, I can say this is factorial 5 and this is nothing but factorial 2. Okay? Or I can say this as, instead of saying factorial 2, I'll say factorial 5 minus 3 factorial. Is it making sense so far? Everybody? Say what's
Yes.
Chris?
Yes.
Sarah, Neil, everybody? Savia, Ritika?
Yes sir.
Yes, sir.
Okay. So, I'm not doing anything fancy here. I'm just trying to connect the dots. whatever we have learned, we are trying to create some interpretation out of it. When I have 5 positions, 5 people, this becomes 5 permutation of 5, which is factorial 5, or I can also write this as 5 minus 5 factorial. Now you will say, so see, I am trying to derive a formula out of it. Now 5 minus 5 factorial, okay, 5 minus 5 factorial or 0 factorial, this equals 1, okay. You will say why. So we all know that if we talk about factorial 1, it means 1. Factorial 2, it means 2 comma 1, 2 multiplied by 1. Factorial 3, 3 multiplied by 2 multiplied by 1. Factorial n means, and you start with n, multiply that with n minus 1, multiply that with n minus 2, and you keep going on till you come to 1. So, how does it come into play? Ideally, I mean, if you look at this means 0 multiplied by 0 minus 1 and keep multiplying till you come to 1. Interestingly, it will look like it is 0. Yeah. But mathematicians have come to a point saying, okay, fine. This starts from a number and goes on till 1. You keep on multiplying it, but then they came to a common consensus, say, okay, no, we will not keep this value as 0. Let's assume or let's agree to a point that factorial 0 will also be 1. Like anything to the power of 0 equals 1, that we have proven. I don't have a way to prove this. This is just an agreed point. Scientists said, okay, since you're talking about factorial and you keep on going till 1, so it's assumed that the minimum that you can think of would be 1. So let's agree and say that, okay, factorial 1 and factorial 0 both equals 1. So factorial 1 is 1, that is proven. There is no need to worry about how to prove it. But factorial 0 is assumed to be 1 because the whole definition of factorial starts with the fact that it starts from a number and goes on till 1. So 1 is the minimum that you can think of. Even if 0 is less than 1, it's a forceful setup where I was myself not convinced with the theory given to it, but then I was forced to believe that yes, this is what it is. So this is the only thing that I'll kind of forcefully convince you guys to agree to, but factorial 0 is 1. Okay. So now going back to the whole thing that I was talking about, where we said 5 things to be filled by 5 permutation 5 equals factorial 5, or we can say this 5 minus 5 factorial. Similarly, when we looked at 3 positions to be filled by 5 people, so 5 permutation 3 equals, we saw that becoming 5 comma 4 comma 3 comma 2, not comma, multiplication 1 into 2, and that became factorial 5 divided by factorial 2, or we term that as factorial 5 divided by 5 minus 3 factorial. Okay. So from this, what you can see is, if I have n permutation n, that means, let's try relating that. So this, whatever you have in the beginning, that becomes your numerator, factorial of that one. So it becomes factorial of n divided by this minus this, first and second one. Similarly, this minus this, right? So we can generalize that with a formula which says this equals n minus n. Or for the sake of simplicity, I will not say n minus n permutation n, I will say n permutation k. That avoids a possible confusion that we will have otherwise. Moment of silence to digest whatever I have blabbered so far. Are you guys with me?
Yes, sir.
Okay. Sara, Neil, Sravya,
Yes, sir.
Anjika, and it,
Yeah.
yeah, okay. Chris, Ananya,
Yes, sir.
okay. Yeah,
I
yeah,
kind of don't understand.
yeah. Say that again, Vera. It's okay.
I said I kind of don't understand.
You don't. Okay. So let's do a very simple example. Now let's say I have 5 colored markers. This is blue, this is purple, this is green, and this is black, and there's a red one also. And there's a red one. I have 5 markers, a Sharpies, whatever you call it, and I have 3 boxes to color. Okay, so I can choose, and the only condition I have is I cannot make all the boxes in one color. They have to be different. Meaning, when I'm trying to color the first box, how many ways I can do? I can pick blue, I can pick black, red, purple, blue, red, purple, black, green. These are the 5 colors I have. So I could choose one of the 5 colors. So I have 5 options to color this box. Yeah. Now, after filling the first box, I still had 5 markers, but since the condition that I had was I cannot choose the same color. So for coloring the second box, I had 4 options, right? Because blue I have already used. So when I was trying to color this box, I had 4 options. I chose red, that's it. So here I had 4 options. Except blue, I could pick any of the 4 options that I had. After coloring the first 2 boxes, then I still had 5 markers, but 2 were already used. So I had to pick one of the 3 that I was left with. Make sense so far, Ananya?
Yeah.
Yeah. So I picked green. But while I was picking green, I knew that I had 3 options that I could pick from. Yeah. So in this situation, the number of options that I had, if you kind of try relating that with the concept that we were learning in the previous classes, how many ways I could color these 3 boxes, that actually gets multiplied. So the total number of options I had was 5 multiplied by 4 multiplied by 3. Yeah. If, imagine a situation where I have in fact total 5 boxes and I had to color them all. Again, same condition, I cannot repeat the colors. So then, after coloring these 3 boxes, the 4th box I have the option of, I have 2 options, black and purple. Meaning I have 2 options here. And then after everything was done, then I had no other choice but only one option to color this box. Yeah. So this was my one option. So if I had 5 boxes to be colored and 5 different colors to be chosen from, and with the precondition that none of the colors can repeat, I had this many options. And in that case, it would have been 5 times, 4 times, 3 times, 2 times 1. But we are talking about a situation. So this would have been factorial 5. This many options we had. Now we are talking about a situation where we did not have 5 boxes. We had to color only 3 boxes. So we had this many options. Just 1 second. Yeah. So when we had to color only 3 boxes with the 5 colors, this many options we had. So we are trying to generate a formula out of it. When I had 5 boxes, we had this many options. 5 till 1. When we have only 3 boxes, we are only going till this one. So we are trying to generate derive a generic formula out of this. We had this many options if I have to color 3 boxes out of 5 colors. So far it's okay, right, Ananya? Everybody?
Yeah.
Yeah. Now, how do I generate?
You,
Yeah.
what is 5 though?
What is that?
The sign next to 5. Like what is that sign?
That's called factorial.
Factorial. So
Yeah. So when you do this, there's a shorter version to represent that. That's called factorial 5. If you have, let's say, factorial 3, this means 3 times 2 times 1. So you start with that number, keep decrementing by 1. Okay. So if you have factorial n, that means n multiplied by n minus 1 multiplied by n minus 2. You keep going on till you come to 2 multiplied by 1.
Okay, got it.
Now, here, what we are saying is, when I have to fill 3 boxes with 5 colors without repeating the colors, this is what my options are. Or this many options we have. This many ways we can, this is the way we can kind of choose different options. Now, we are trying to generate a formula. But we don't like writing this many numbers. We want to use a shorter version like this. If I have to do factorial 200, imagine how many pages it will take if I have to write it in an expanded form. They are shorter form. So we are saying, okay, fine. Can I do this instead of writing 5 times 4 times 3? Yes, I can do it, but I'm not supposed to change the value. So if I'm multiplying on the numerator, let me divide as well so that the overall value doesn't change. So I'm still filling 3 boxes with 5 colors, and this is my option. So this one I can write in a shorter form, which becomes factorial 5 divided by 1 multiplied by 2, which can be written as factorial 2. Yeah. So far, everybody with me?
Yeah, that makes sense.
Yeah. Now, I'm still not happy with what I have done so far. So I'm just trying to, again, my intention is to come to a generic form. Here I'm saying 5 boxes with 3 colors. Here I'm saying 5 and I'm saying 2 here. So 5 and 3 is not kind of connecting the dots for me. So what I can do is, instead of factorial 2 I can write as 5 minus 3. Correct? Now this is teaching a story for us. I have 5 positions to be filled with 5 colors to pick from to fill 3 boxes. So that becomes more like a formula for us. Now we can, so 5 colors, 3 boxes. So 5 options to choose from, this many positions to be filled. So now if I try writing this like a formula of permutation, I can say 5, this is equivalent to this, which means factorial 5 divided by 5 minus 3 factorial. Yeah? This became a formula for us. Now, you relate that back with the original thing that we were trying to do, filling 5 boxes with 5 colors. In that case, if I extend that formula and say like this, 5 colors to fill 5 boxes, this will be factorial 5 divided by first one minus second one, factorial, which is factorial 5 by factorial 0, which I kind of forced you guys to believe that this is equals to 1. Yeah. So this has come to a point where we have looked at how things work and how permutation actually helps us do certain things in a much more simpler and a smarter way. So the formula that we learned for permutation is 5 permutation 2, or let's put it in a generic form, n permutation k. That means permutation of the first number that you see here, so factorial n divided by first number minus second number factorial. This becomes our generic formula, and that is coming, it's not coming from nowhere, it is coming based on what we saw when we were trying to fill 5 boxes with 3 colors. Yeah? Is everybody with me so far? Unless I hear a loud yes, a confident yes, few thumbs up on the screen, I don't get confidence.
Yes, sir.
Yes, sir.
Okay, good. Chris, Sarah, Neil, Sravya, Ritika,
Yes, sir.
Srivatsav,
Yes, sir.
Anjika, everybody. And please excuse me for being a very nagging teacher. I keep nagging everybody, okay? Yeah? Alright. Okay, so I will assume that there is no confusion with whatever we have done so far. Now, let's see how that helps. If you guys got a chance to look at the message that I had sent in WhatsApp, right? What are the topics that we are going to cover? If you look at some of the things that I mentioned, factorial usage, that's okay. We have seen what is factorial used for. Forming words with letters, repeat and non-repeat words. We'll come to that one. Color combinations, okay. So we looked at, now let's look at a situation how we can use this thing, okay, and that is where you will see the relevance of this. Again, this is not like a silver bullet where you can just apply. Let's use a little bit of thoughtfulness before we try solving a problem. Let's forget this formula for a little bit, okay? We'll come back to this. Now, don't laugh at me, okay? My English is not as good as you all. So I'm using simple words here. Act, cat and tap. These are three words. What do you see here? All of them are using same letters, A, C and T. Yeah? This is a classic example of permutation. Meaning, you can jumble these three words, these three letters, to make different words out of it. Act and cat are never going to be same. Yeah? There will be other words also that can be formed out of it. And again, these words might not make much sense, but we are just looking at from a permutation point of view. So the three letters I had was A, C and T, and these are the words that we can form, and yeah, there are 6 words that we can form. So you are seeing a classic example of a permutation, meaning you have 3 letters and you have to jumble them up to form words without repeating any of them. We did not talk about A, C. No, we are talking about all the characters being unique, none being repeated, and then how many ways we can do it. Now look at the formula that we have learned, which says NPN or NPK, meaning how many options, how many words, or how many combinations to pick. So we have to pick words with from 3 letters. So this is 3, and we have to make words which is also of 3 sides. We are not talking about AC as a word. We are talking about a word with 3 letters into it. If you put this here in this formula says this will be factorial n divided by factorial n minus k. So here your n is nothing but 3. N minus k, n and k both are same, 3 minus 3, factorial of that. This becomes factorial 3 divided by factorial 0, which essentially is equal to 1. So factorial 3 becomes 3 into 2 into 1 divided by factorial 0 is 1. You got 6. You can literally put this value here in this formula and tells you how many words you can form if you have to use all the characters without repeating any of them. Yeah. So instead of doing this hard work the way I did in the beginning, that was probably not needed. You could have simply applied the formula to get how many you can form out of it. How many words you can form out of it without repeating any of the letters and without repeating the same sequence. Are you guys with me? Yes, Chris.
Like, can you apply this formula like with the stuff we learned last week? Like the example you were talking about with those three like Honda, Toyota, and all that, and then like the two-wheeler and all that. Can you apply all that in this formula?
We can pick up a question and we can try applying it. So let's play with that, okay? So that's the purpose of this class, right? We don't learn, we play. Let's play. Now let's talk about. We have. So see again, what we learned in the previous class, that was just to understand how do you form factorials, right? Let's say if you relate that with what we did, that you have two brands, Toyota and Honda, and every car brand gives you three colors: black, let's say red, and yellow. And then in every variant of the color you have two-wheel drive or four-wheel drive. So how many total options you have? If you have to pick one car, say okay fine, 2 multiplied by 3 multiplied by 2. That becomes the number of options. Here you will not be able to apply this into this formula as is. The reason being you're not trying to. So if you look at permutation, okay, what you are essentially talking about, you're talking about this is the number of things you are putting together with number of options you have. This is for lack of better analogy, this is a scenario where dealing with 2 parameters, here you're dealing with 3 parameters. So you're not going to apply it as is in this formula is what I was trying to say. But, Chris, did I answer your question or I got you confused more?
No, I think that did make sense.
Yeah.
The number of parameters also matter.
Correct. And see, you can even have a next level of situation to deal with where you'll say, okay, fine. You have 2 brands, 3 colors, 2 drive options, and then you have luxury, limited, and general edition. And then if you choose a car, then you're talking about 3 options here. How many options you have? And then you say, okay, fine, 2 times 3 times 2 times 3. You can go for a Toyota, blue color, 2-wheel drive and luxury segment. You can go for Toyota, blue color, 2-wheel drive, limited edition. You can go for like the tree structure that we had formed in the previous class, right? So instead of forming the tree and making it going for a cumbersome option, you can simply multiply them and you will be able to derive how many options you have to choose from. Similarly, when you're looking at permutation, you're essentially talking about 2 parameters and looking at how many ways you can organize them or how many ways you can come up with the permutations. Yeah? What are the permutation options you have? Yeah? Everybody with me, right? If I ever confuse any of you, raise your hand, shout back. Yeah? Ritika, do you have a reason to fight with me today? Not yet?
Not really, sir.
Okay. So again, as I keep saying, right? I mean, there could be a situation where I explain something to you which is not clear. Please ask me for clarification, okay? Dhanushri, for you also, okay? Everybody, not for any, just for the name that I'm calling out. Yeah? Sarah Neil with me?
Yes.
Okay. Ananya? See what's up, everybody? Okay. Now let's play with what we have learned so far. Let me give you 2 situations, okay? We'll not try solving it. I'll just make you guys first think and then tell me, okay? You have to form a, let's say, a 4-letter word. Okay? You have to form a 4-letter word by choosing any of the 26 characters you have in English. Okay, you have to form 4-letter words. I'll not say word, 4-letter words by choosing any number of, not any number of, but you have to build 4-letter words from these 26 characters. There are two situations. One is when you can repeat letters or the alphabets, and second situation is when you cannot repeat alphabets. Now tell me, how will you solve in both the situations? Let me repeat again. There are 26 alphabets. I'm asking you guys to form a 4-letter word. I'm asking you to form 4-letter words. First situation, without repeating alphabets. Second situation, you are allowed to repeat alphabets. So what will be your answer in both the situation? And more than answer, tell me how would you think about these two problems? Anybody? I believe you would not want me to put any of you on the spot, but yeah, I'm still wanting to hear. And it's okay to go wrong, it's fine. I have just taught you guys something. I'm trying to make you guys think and give me an answer. And it's perfectly fine if you go wrong. That's what my job is, to do the correction. Okay, fine. I believe on a Saturday afternoon you guys must be feeling a little sleepy. Let me wake you up. So, is anybody wanting to give it a try, or if any of you want to explain this to me with whatever is going in your mind? And it's okay, nobody is going to laugh, nobody is going to question, nobody is going to think anything about it, okay? And does anybody want to give it a try?
Can you repeat the problem?
Yeah, so you have 26 alphabets, yeah? We are trying to form words with four of them, 4 alphabets, or a word with length 4, okay? So first situation is, I'm asking how many ways what is the number of options you have to form a 4-letter words when you cannot repeat the alphabets? And second part of the question is, what will be the number of options that you will have when you are allowed to repeat the alphabets?
So like the first one's the permutation, the second one's the combination, right? Is you're allowed to repeat?
Sorry, say that again, Mila?
So the first one, you're not allowed to repeat any letter from the alphabet, so that's a permutation, like it has to be in order.
It has to be in order, or at least you have to make sure that none of the alphabets are repeating.
So is that like 26 times 25 times 24 times 23?
Yeah, that is correct. How about the second one?
26 times 26 times 26.
I love that. I literally love that. I could see the amount of thoughts you have put behind it. Yep. See, not every math is a difficult problem, correct? So you just thought about it. When I said in the first situation you are not supposed to repeat, and second situation you are allowed to repeat. So now let me do it like a kid's way, right? If I'm not literate enough, still I want to solve this problem, I'll create 4 boxes. These are my 4 boxes, which I will fill with alphabets. Instead of coloring them, I will fill with alphabets. Okay? Now, I have 26 alphabets to pick from. When I'm not allowed to repeat, that means when I'm picking the first box, nothing is used so far. I have 26 options. I picked one of the 26 options here. Then I go to second box, meaning try to form the second letter of the word. One is exhausted here. What I'm left with is 25, 24, then 23. If it was a 5-letter word, I would have had one more box, and that would have been 22. So the total number of options that we have, relating that with the card theory that we did before, it will be this many options. This is the simplest way to look at it. Now, you can also, this will be the answer. Second way to do it would be like the permutation way. You will say n and k formula, where this is n factorial n minus k. Here your n is nothing but 26 options you have. So factorial 26 divided by factorial 26 minus size of the word is 4. This factorial. So essentially this becomes factorial 26 divided by factorial 22. And that is where you will see that factorial 26 you can write as 26 into 25 into 23 multiplied by, what did I do? Yeah, 26, 25, 24, 23 multiplied by factorial 22. I just split that into 2 parts and then divide by factorial 22. So I can do tic-tac-toe with these two. Yeah. So if you see this one, I can do that in a simple way like this, or I can apply that understanding of permutation here to find the same value. So far everybody okay?
Yes, sir.
Sarah, Neil, Srivatsav, Rania, Chris, Sravya, Anjika,
Yeah, I'm good.
Dhanusri.
Yes, sir.
Okay, wonderful. So this was one way to solve it. Okay. So again, all of you who have heard my most boring speech with Tran, right? New for Anjika. So this is my magic wand, which I prescribe to each of my students, saying, okay, you apply Tran while solving problem. Trust yourself that you can read. Trust yourself that if there is a problem that anybody can solve, that is you. So that trust has to be a part of your character. R stands for read, meaning read the question again. As many times till you get tired and you extract all the information out of it. So reading is a very, very important part. Then you analyze, then you start thinking about it. That's where I was kind of bugging you guys to tell me what is going in your mind, right? So trust yourself, build that as part of your character. Read, then analyze, and then comes N, which stands for Nike. Just do it. So what it means is, read the question enough, analyze and build your thoughts, how you're going to solve it, and then you recall Nike, which says just do it. Nike, I'm not a brand ambassador for Nike, I'm too small a guy to even be a brand ambassador for anybody, but then I like the punchline. So here in this case also, if you look at the way this can be solved is, you just have to read the question. There was no cryptic part to it. You just have to read or hear me a couple of times, okay fine. You said in the first situation, you cannot repeat alphabets. Second situation, you can repeat alphabet. So we have not come to the repeat part of it yet. But in this situation, when once an alphabet is consumed, you are not supposed to touch that. And any which way, once you pick one of the 26 alphabets here, that one is going to be gone from the scene when you go to the second one. Likewise, when you go to the third one, 2 are already consumed. You are left with only 24 options. You just multiply them, that gives you a total of options that you have to deal with. Or you can use the generic permutation formula that we learned to solve it. Any which way. I mean, you have 2 options here. Now, this is okay to digest so far, right? I have not told anything which is sounding complex. Yeah, Chris.
With the answer you got for like 26 factorial or 22 factorial, is that if the letters can repeat or if they cannot repeat?
They cannot repeat, right? Because if you look at this, when I am looking at the first box to be filled, first letter, I had 26 options. When I went to the second one, I had 1 option less. And that kept on decreasing, right? That is how I got this answer. I was just telling this is the second way to solve the same problem. Answers in both the scenarios will be same. So this is to do with when you are not supposed to repeat. Yeah?
Okay, got it. Thank you.
Now when we are talking about repeat option, that is an easy peasy one. So it's very simple. I'm saying you have 26 alphabets, you have 4 boxes to fill, and I'm saying that you are okay to repeat. Meaning, if I'm using A here, nobody is stopping me from using A here as well. Here too, here too. I don't know what 4 A's mean, but yeah, you'll get a distinction if you're getting it. Yeah, your CGPA will get better. So I'm sure many of you have much better CGPA than this one. But yeah, coming back to the point, in simple terms, every box can be filled in 26 ways. Every box can be filled in 26 ways because there is no limit, there is no restriction. So this thing becomes total number of options that I have is this many. And here you don't have to use the permutation formula because permutation formula applies when the ordering of the elements matter. Here the ordering doesn't matter. You're saying that even if you have consumed 1, there is no limit here, there is no limit here, there is no limit here. That is where the permutation formula will not fit. You have to do it in a simpler way. Yeah. So when you have a question, that is when the R of the trad is so very important. When you read this again and again, you will know that okay, where you have to use the formula versus where you have a simpler approach to solve it with simple application of logic. Yeah. Is everybody with me so far?
Yes, sir.
Okay. Anjika, are you able to follow whatever I have said so far?
Yeah, I can follow.
So all these kids, all the other kids except you are used to dealing with me. You are the first. You are a newbie in the group, so that's why I'm checking with you. Not with the intent to put you on the spot, but yeah, just to see. Yeah.
Yeah, okay, I appreciate it.
Yeah. Yes, Chris.
With the 26 times 26, like with the answer you got, how do you write that in mathematical form?
So there's no mathematical form for this one. Okay. So this is if you can relate that with the car example, right? Toyota, Honda, 3 colors, blue, black, red, and then let's say 2-wheel drive, 4-wheel drive. You have 2 options here, 3 options here, 2 options here. You simply multiply them. Okay? There was no formula that I had given for this one, right? Because you know that if you explode that to a T structure, this is your Honda, this is your Toyota. Honda gives you 3 colors, Toyota also gives you 3 colors. And then every color gives you 2 variants of 2-wheel drive or 4-wheel drive. Blue, black, red. Blue, black, red. Honda, Toyota. 2-wheel, 4-wheel, 2-wheel, 4-wheel, 2-wheel, 4-wheel. Here also same 2-wheel, 4-wheel. Same thing here, same thing here. Now, the cumbersome approach that we had was we had to count all the trees. Okay, I can go this way, this way, this way, this way. And then you found that okay, it simply multiplied this many options multiplied by this many options, this level, and this level, you multiply them. Similarly, when you look at every position can be filled in 26 ways. Every position can be filled in 26 ways. You should relate it this way, right? Imagine, go from here. First position you can fill with 26 ways, in 26 ways. Now, this position, when you are filling this position, for every one of this, you have 26 options. So if you are looking at only this combination, it becomes 26 times 26. Because for every one, you have 26 options. Second one, you have 26 options. Third one, you have 26 options. Correct? So that is how it becomes 26 times 26. Similarly, when you go one level further up, you see that this combination, every combination coming from these two maps to one of it. So you have 26 options. So when you come to this level, you end up multiplying by 26. When you come to this level also included, you see that all the three combinations, the number of combinations that you have got with these three in place, entire bundle maps to one of the elements here. And you have 26 here. So 26 times. Is it making sense now?
So if you want to make a 4-letter word and we have like 26 options, so would it just be 26 raised to the 4?
26 raised to the 4. Yeah.
Okay.
Yeah.
Got it.
Yep. Krisa, are you able to follow as well? I realize that Krisa also has not attended many classes so far. So it gives me a reason to bother her to.
Did you say my name?
Yes, yeah, I did. I was just checking because I think this is your second class as well, correct, Krisa?
Yeah.
Yeah, so that's why I was checking whether are you able to keep pace with the way I'm explaining things, or would you want me to tone down a little bit?
I'm able to understand.
Okay, wonderful. Yeah. So see, it's like a habit, right? Good or bad. So once you spend some time with the teacher, then you will match my wavelength, I will match your wavelength. But till the time that transition happens, we have to keep on putting the effort. So that's what I'm checking. Okay. All right.
I have a question.
Yes, Beta.
Will we be like learning this next class too, or are we gonna move on?
So far we have only touched the permutation part of it. Now we are going to do combination. So permutation, combination, then we'll relate this understanding with probability. So that makes it a complete bundle. So far we have looked at permutation where the ordering matters, right? Now we'll go to the next level, which is combination, where the ordering doesn't matter. Okay, and we'll try learning that. So we have learned concepts of permutation, how do we relate that with the formula, and how do we solve different problems. And obviously I'll let you guys do unit test on Khan Academy, so that you can see if these concepts that we're learning in the class, are you able to apply them while solving. If there's something that is tricky or complicated, obviously you'll come back to me saying, sir, what you explained was not good enough for solving this problem. Can you solve this for us? Yeah.
Okay.
Yeah. Now let's go to next situation. How much time do we have? Oh, we have only 2 more minutes. So in the next class, I will try to avoid talking about permutation because we have talked about it quite enough. We'll focus on combination, and then we'll try relating that with the concepts of probability. Okay. So, but before we say that we are good for today, let's spend few minutes to touch the tip of the iceberg when it comes to understanding the difference between permutation and combination. Yeah. I see kids are joining from the next class, but we'll just take 2 more minutes. We still have 2 minutes. So when I was talking about permutation, I mentioned that permutation clearly refers to the fact that the order matters, meaning ACT and TAC are 2 different things when you look at it with the lens of permutation. But in case of combination, it doesn't matter. Combination says that it's a group of 3 letters Now let's try relating it that this way. Okay, so I see some kids from the next class have joined, and I will request them to be on standby for maybe 2 more minutes. We'll start your class in 2 minutes after we finish, the class for the senior ones. Okay. All right. So here, the basic difference that you would want to keep in mind is this. If let's say I have 26 alphabets and I have to form a 3-letter word, this is permutation, okay? Where ACT and TAC are different. But when you look at combination, it says, okay, you have ACT, TAC, CAT, all these are formed by 3 characters A, C and T. Doesn't matter whether you have they being jumbled up or they being in the same order, as long as the number of characters are same, or the actual characters are same, the alphabets are same, this will be treated as one combination. Okay? So basic difference, in permutation the order matters, combination only the elements matter. Okay? These are all same, wherein this is different, because this is a combination of B, A and T. This is a combination of A, C and T. So combination says this is a different combination, this is a different combination. Permutation says these are all different. Okay. So in case of permutation, the ordering matters. In case of combination, the elements matter. Okay. That would be the starting point for combination or relating permutation and combination. We will go deeper into it in the next class, and then we will try breaking our head with that. Yep. In tomorrow's class, we'll talk about combination and then relating that with probability. That will complete this particular unit or topic, and then we'll move on to the next topic in the subsequent weeks. Does that make sense? Are you guys okay with that?
Yes.
Okay.
Yes.